Every single winter, it's the same story, isn't it? The sky over Delhi just turns this hazy, toxic gray, and something as simple as breathing becomes a health hazard. It's a crisis that comes back like clockwork. But why? I mean, really, why? What is it that turns one of the world's biggest cities into a virtual gas chamber for months on end? Today, we're going to break it down. We're dissecting the anatomy of this perfect storm to figure out exactly how it happens. Okay, let's start with this. 425. This isn't just some abstract number. This was the reality on the ground in Delhi during a recent winter. That's the Air Quality Index, the AQI. Now, just so you know, anything over 300 is officially labeled severe. So 425? We're way past severe. We're in territory that's a serious risk to absolutely everyone. This is the emergency we need to understand. So that really brings us to the big question, the one we're here to answer. This isn't some random fluke event. It's a predictable, annual disaster. So why? What is it about winter, specifically, that triggers this crisis year after year after year? You know, it's a super complex puzzle, but it's one with clear, identifiable pieces. And here's the key to the whole thing. The answer isn't just one single villain. It's not just the cars or just the factories. It's what you'd call a perfect storm, a really disastrous combination where a bunch of different factors, both natural and man-made, all collide at the exact same time. And together, they create a crisis that's way, way worse than any one of them could cause on its own. All right, let's get into the first crucial ingredient in this dangerous recipe. Before we even talk about what's in the air, we have to understand why the air itself gets stuck. The problem actually starts way up, high above the city, with the basic physics of the winter atmosphere. The whole thing is called a temperature inversion. Now, I know that sounds a little technical, but the idea is actually pretty simple. In winter, you get this layer of warmer air that just kind of drifts in and sits right on top of the colder, heavier air that's down at ground level. And that warm air acts like a giant invisible lid, stopping the cold air below from rising and getting up. Look at this. It shows you the difference so clearly. On a normal day, right, the sun warms the ground, that warm air rises, and poof, it carries all the city's pollution up and away. But during a winter inversion, that whole process just gets shut down. That warm lid presses down, and all that gross, polluted air gets trapped right where we are, right where we have to breathe it. And as if that's not bad enough, that trapped air, it's not going anywhere. Winter wind speeds in Delhi often just plummet, sometimes dropping below 10 kilometers per hour. Sometimes they stop completely. So you've got a lid on the city and literally no wind to blow the pollution out. The air just sits there. It becomes stagnant, and the pollutants just build up and up and up, day after day. So the atmosphere has set the trap. Now we get to the second ingredient, the poison itself. What are we actually pumping into this sealed-up atmospheric box? This is where our human activity really comes into play. Let's take a look at the toxic cocktail that actually makes up Delhi's air. This chart here, this is based on some really recent winter data, and it gives us a clear picture of the culprits behind those super dangerous little particles, PM 2.5. And right away, you can see two huge players that just jump out. You've got vehicular emissions at around 20%, and then this surprisingly massive slice, about a third of the whole problem, labeled secondary pollutants. Let's start with the one we can all see and smell. At 18 to 20%, cars and trucks are the single biggest local contributor. We are talking about a constant, never-ending stream of exhaust from millions of vehicles, all pumping pollutants directly into that trapped layer of air right at street level. But this right here, this is the really critical part, and it's something the latest data has made crystal clear. Almost a third of the worst pollution isn't coming directly out of a tailpipe or a chimney. It's something called secondary ammonium sulfate. And honestly, understanding this is a total game changer for understanding Delhi's air problem. So, what in the world are secondary pollutants? Well, they're basically particles that are born in the air itself. You have gases like sulfur dioxide from power plants or ammonia from farms. They get released into the air. Then, in the unique, humid, foggy conditions of a Delhi winter, these gases actually have chemical reactions and transform into solid, breathable, toxic particles. It's literally chemistry happening in the sky right above the city. And of course, you've got other stuff getting thrown into this mix. There's biomass and waste burning, especially from people just trying to stay warm on the street. And then there's the constant construction, which kicks up all that coarser PM10 dust, adding yet another layer to the toxic soup. Okay, So we have an atmospheric lid, we have a cocktail of pollutants. But what makes the trap so inescapable? Well, the final ingredient is geography. Delhi's physical location on the map is the very last piece of this puzzle, the thing that locks the whole crisis in place. It's known as the basin effect. You see, Delhi sits in a kind of geographical bowl. You've got the massive Himalayan mountain range to the north, acting like a giant wall. This natural barrier just blocks weather systems and winds from being able to effectively clear all that polluted air out of the region. The city is, for all intents and purposes, in a natural trap. And this basin, it doesn't just trap Delhi's own pollution. Pollutants from industrial neighbors like Jhajjar and Rohtak, they drift right in, and smoke from regional crops double burning, that also gets funneled into this geographical bowl and gets completely stuck. It makes it so clear that this is a regional problem that just gets concentrated right over Delhi. So there you have it. We've looked at the atmospheric lid, the cocktail of poisons, and the geographical lock. So right now, let's put all those ingredients together and see the full, clear picture of how this perfect storm actually forms. And this lays it out perfectly. It's a sequence. Step 1, the winter weather creates that temperature inversion, that atmospheric lid. Step 2, a constant stream of human activity, traffic, industry, all of it, fills that trapped air with a toxic cocktail. And then finally, step 3, Delhi's basin-like geography makes sure there is absolutely no escape. So here it is, the most crucial point to take away from all this. It's not any one of these things on its own. It is the deadly interaction between them. The weather creates the conditions, the pollution provides the poison, and the geography seals the deal. That synergy, that combination, is what turns a bad pollution problem into a public health catastrophe every single year. And that leaves us with one last, vital question. Now that we understand the incredibly complex recipe for this disaster, now that we know the ingredients of this perfect storm, what on earth does it take to finally unmake it?